you know about Tizen? So what is it? Someone? What is Tizen?
It's an OS, mixture of Android, Linux, Bada. That's how I see it. I may not be accurate.
Yeah.
And
So,
patronized by many companies.
so how many of you are aware of the concept of IoT, Internet of Things? So, yeah, so basically it's a new breed towards that actually flourished that concept. So, myself, I work as an application security engineer for Yachtley, and I do blog about a lot of stuff. I put all my research in a blog that is called opensecurity.in, and I had spoken at a couple of other conferences. And I always love to do new things and also to learn new things. Okay, so that's a disclaimer. Okay, the agenda of the talk is that I'll just give an introduction about what is Tizen and why Tizen is going to be a big hit, and then the the basic Tizen architecture, the type of application, the structure, and I'll quickly jump through the security model, what they have compared to other operating systems. Then where I'll talk about SMAC, which is nothing but the sandbox of Tizen, and then I'll talk about WebKit2, which is used by Tizen, and then a quick comparison between Android, iOS, and Tizen regarding the security features. And we'll stop all the theory thing and we'll quickly jump into the interesting part, like hacking Tizen, where I'll discuss what all, the research outcomes on hacking, which I had done on Tizen. And for the pen testers over here, I'm pretty sure like by the mid of 2014, all your devices will be of, I'll talk about that later. So I'll talk about the pentesting methodology also. And then I'll talk about the security concerns, and finally I'll conclude. That's it. So Tizen is basically, it's OS of everything. So there is a concept of Internet of Things. So which basically means that starting from your electronic devices like your TV, your watches, your mobile phones, going to your your vacuum cleaners, your refrigerators, your microwave ovens. So everything in the future will be shipped with an OS. So initially we have a concept of smart home. So all these big gangs, all those hardware vendors, all the software vendors, they're actually coming together and they're bringing up an OS which is applicable for every electronic device out there. So people actually initially thought that Tizen is just another mobile operating system. So I would say that's not the right way of taking it. It's actually an OS for everything. It's not just a bare mobile operating system. And one more thing is that it's an open source project, and it is basically supported or funded by, not funded, but supported by the Linux Foundation. Yeah. So as I talked before, it's a smart home. It's actually pushes the IoT concept, that's a smart home concept. So in future, every device you have that is having some, every electronic device you have will be having an operating system, and that will that allows you to control it in a centralized manner. So that's the concept that this IoT is pushing. So Tizen is a new thing to that, to adapt to that concept. So basically, why Tizen? Yeah, so that question comes up. So if you look into the news, you can see that Samsung is like desperately losing the market. Like if you see, Micromax had already beat Samsung in terms of mobile. So and there is a lot of open source or closed source policies with Google, which is keeping Samsung away. So they want something which is more open. And already Samsung worked on a lot of things like Bada, Amigo and all, and it didn't really work out. So now they're actually looking for a comeback. So for that, Samsung with all those gains like Intel and other 36 companies, they're actually coming with a new competitor called Tizen to, fight against the competitor Android. So these are some of the big gains that currently support Tizen, like Fujitsu, Hawaii. All those big hardware, software, as well as the carrier people are over there, like Vodafone, LG, Samsung. These are the people over there. So this is a bit overview of why Tizen is going to be a big hit in the future. And basically, it's like any other operating system. In Tizen, you can have a native application, you can have a web application, and you can have hybrid application. So the difference is like if you compare with Android, if you have a web app in Android, it's like basically it's pure web app. It cannot access anything outside the browser or the web view, right? You have to have some JavaScript interface or something like that. But basically, it doesn't allow anything out of the box. But the advantage of Tizen is that it actually ships with a set of JavaScript API called the Web API, and it's giving more power to the developers. So the advantage is like if you are a web developer, you can very easily jump into Tizen development. You don't have to know about the native C++ or anything, because you can just create a Tizen project in web. You can write everything in HTML, CSS, JavaScript, plus those JavaScript APIs which are provided by Tizen. So this is basically the Tizen architecture. So in Android, you have .apk itself, right? So you have the hybrid application, web application, whatever. It's a .apk file. But in Tizen, you will be having two types of files. One is a .tpk, that is a native application which are written in C++. And then you have Tizen web app, that is like having an extension .wgt. It's a widget. So the advantage is that both of them can actually access all the features provided by the device. Like you have that SMS, security, whatever, metadata, location, GPS, geolocation, whatever. So now your HTML is and your JavaScript is so much powerful here with Tizen. You don't have to worry about, even if you don't know like to code in C++ or whatever, you can, if you're just a web developer, you can directly jump into Tizen web app development. And the interesting thing is that their Play Store is, their Play Store alternative that is open and is free. You don't have to pay that $25 fees. Just saying. And this is all about the architecture. And this is a web API which I have been talking about. So these are basically JavaScript function which allows you to access all those device features. It's not directly working that way. You have to have a lot of permission. So it's all based on a permission model like the way your Android is having, if you're familiar with Android. So I'll come to that. And basically, I'll talk about the application structure. So there can be native application, web application, as well as hybrid application. So in Tizen, basically it's a Linux-based OS. It's whatever it is, it's it's built on top of Linux, like they did with Android. So this is a directory where your application get installed. It's like /opt/user/apps, and inside that, whatever the application you install, it will be having a string of 10 of length 10, which is having some random alphabets and numbers. That's it. So in Android, the similar thing is like you have com.google.play or something like that. But here it's called a package ID, and it will be like a string of length 10, and it's having some random alphabetic numbers and digits. That's it. And this is a native application structure, the .tpk file. So the one that is marked in that red, that is basically nothing but the installation location. And after that, whatever is the content of the APK. So in Tizen, what is happening is whenever you install a TPK, it will just get extracted to that particular folder. That's the installation directory. So whatever is in that TPK, that will get extracted there. So that's what's happening. And similarly with the web apps, that is .vgt. So everything will get installed under /opt/user/app, and then that random package ID, and inside that you have that. And you can also have a hybrid application, which can support both binary, which you can code both in C++ as well as your HTML, JavaScript, whatever. And moving on, I'll talk about the Tizen security model. So like any other operating system, Tizen is also having a good security model, and they are actually boasting a lot about that. They are telling, they actually have a lot of things architecture-wise. Let's see. So the idea is that all the applications are non-root application. That means all the applications run under the same UID, that is app, and there are very few, very few processors or system daemons that is running with root privileges. So, it's the one they have now. It's like they have a lot of processors, but they are actually trying to minimize that. And the application sandboxing. So, like any other Linux-based operating system, they have a sandbox which they call SMAC. You have the sandbox for Android, which is enhanced by SE Linux. So similarly, it's all similar to that. There is something called SMAC. It's something called the Simple Mandatory Access Control. I'll be just going through that also. And then, so basically, as per the sandbox, one application is not allowed to access whatever the other application is having, and vice versa, like IPC, network calls, whatever. And again, like your Android application, it is having the least permission model. So here the permissions are called as privileges. Instead of permission, they call privilege. And all the applications is having a manifest file. And in this manifest file, like you do for Android, you have different permissions. You have the SMAC rule. And in addition to you have something called the CSP, the content security, content security policy. So basically, your web app is actually having a lot of security implementation in Tizen. So Tizen supports CSP for every web application. In Android, it's like you actually load it in a separate component called WebView. But here it's something like every web app supports, it's a mandatory that you have to define the CSP. So CSP is mandatory. And you might think that if I'm doing a lot with, HTML5, JS or whatever, my application logic will be exposed to others, right? So what Tizen do is it actually encrypts your web application. So how it works is like it encrypts the application during install time and decrypt it at runtime. But there is a problem actually. So the thing is like the key is actually stored in the device, but I was not able to figure out what particular encryption what is the method they are using to do the encryption. So since the key is there, I'm pretty sure that you can take that key from the device and decrypt it. So that won't be an issue if you are dealing with some black box pentexting or something like that. And then about the content security framework. So this is one of the pain if you if you think about different operating systems. Like there are a lot of antivirus companies, malware, detection companies, and all those things. So it's very difficult for them to actually act in the law level to access all those, to work at the law level. So normally, if you want to write an antivirus for Android or something like that, it's a task actually. You have to act very low level and do all those stuff. But in Tizen, the advantage is that anyway, it's a Intel company. So, Intel is supporting. So McAfee is an Intel company. So McAfee is providing a set of APIs which allow you to do all this functionality. So any antivirus companies which are actually approved by the Tizen Association or whatever, they can actually make use of these APIs to do all the scanning of the content, the URL, and whatever that is happening in the Tizen device. So that is a good thing the Tizen security model is having. And SMAC is basically, I'm actually not going deep diving into SMAC because it's not my topic of research actually. So basically I'll just give an intro. So SMAC is nothing but it's a sandbox. So basically the basic rule of a sandbox is something like whatever mine is mine and what's yours is yours. So that's a basic rule. So we use SMAC to extend that rule. Like if I want to do some IPC with that particular application and so on. So SMAC is basically allowing that. So that's a role of SMAC. It's not just that. It looks too much complex if you start developing in it. There is something called 41,000 SMAC rules and all, but we are not actually concentrating on those. Okay, so a little bit more about SMAC. It's like there is something called the concept of subject, object, and access. So all your processes, all your running process is called a subject. Your object is nothing but your file, IPC, socket, whatever. And access is the permission. You have the Linux permissions, like Unix permission, right? So similar to that, here we have permission like read, write, execute, append, lock, and there is one thing called transmute. So transmute means it basically gives a file the permission of the app or the directory. If directory is having a permission, that permission is given to the file you are going to create. So something like that. So these are all the SMAC thing. So the only thing we are actually concentrating on here is that there is like 41,000 SMAC rules in Tizen 2.2.1. That is like a huge thing. The developer has to take care of it. In defining and all those things, which it's not a quite good thing. When you complex things a lot, it's a high chance that people will mess up. So they are actually moving to something else in Tizen 3, which actually they are working on. It's called a SMAC 3 domain model, and they're actually trying to reduce this SMAC rule. So anyway, let them do it. Let's see what happens once that is released. And then I would like to talk about this WebKit2. So you know that Tizen applications are, Tizen web apps are basically running over something called WRT. That is a WebKit runtime. So WebKit, you know that there's a lot of exploits, bugs, user outreach, blah, blah, happening on WebKit. So what they did is like they made an API. They use something called WebKit2, which is an API layer over WebKit. And basically what it does is nothing. It's just like your Chrome. In your Chrome, when you open new tabs, every tabs are actually opened as a new process. Each tab is a new process, right? So here it's actually borrowing that particular concept. That's a split process model. Every tab is a new process. So if something happens to this process, it doesn't affect the other process. So that is the concept here. So that's why they are using WebKit2. And okay, I'm about to end all this theory stuff. So I'll just give a quick comparison about Android, Tizen, and iOS. So in Android, every applications are identified by a UID. In Tizen, it's like every user created app is having a UID app. And in iOS, all apps run under mobile. And for the permission-related least privilege model, in Android, you have the Android manifest.xml. And here in Tizen, what you have is like, for the native application, you have manifest.xml. And for that web application, you have config.xml. It's just basically the same thing, but they're actually keeping two files. That's it. And then there is no permission model in iOS. Of course, it's like whenever you run an application, it will ask for the permission and you have to accept it or deny it. That's it. And then for IPC in Android, it's a binder-based IPC using indents. But in the case of Tizen, it's like there is something called message port API, similar to that, which is using socket. And for iOS, it was initially like a lot of workarounds they were using. And now they have something like XPZ-based IPC and all. And in Android, the sandbox, with the Android sandbox, to harden it, they have the SC Linux, which is fully implemented to Android. In Tizen, they have the SMAC plus the content security policy. Content security policy is specifically for the web application. That is mandatory. And the signing model is like, for Android, it's like, okay, in case of iOS, they have Powerbox or Seatbelt, something like that, as a sandbox. And then for Android, every APK is signed by the developer. In Tizen, they have a different model. It should be signed by the developer as well as the distributor. That is a store guy. And then for iOS, it's a distributed sign. So this is a quick comparison. Okay. So enough of it. Let's look into what are the issues in Tizen. So my research is actually focused on the Tizen web apps, Tizen OS memory protection, and Tizen CSP and WebKit as of now. It's an ongoing research basically. So these are the things I will cover today. Before that, I'll just make a quick comparison about Android web app and Tizen web app. So basically, if you want to leverage the device functionality like Bluetooth, NFC or Wi-Fi from the web app, from a web view, in Android there is something called Art JavaScript interface, right? I mean, we had a lot of buzz around that, like those reflection issues with the reflection-based APIs in Java and all, but that was fixed. But still, they are using something called Art JavaScript interface. So what the developer has to do is he has to expose this API to the Art JavaScript interface so that the web application can access this via the bridge. In Tizen, instead of that, it already provides a set of web APIs which you can directly fire. And it's actually protected by those permission model as well as CSP. So I'll give a scenario. Consider you have an overprivileged Android application. So, I mean, I'm talking about the web application, okay. So what can go wrong compared to an Android application and Tizen application? In Android application, you have web view. And if you want to access some device functionality, you have to use Art JavaScript interface. And say, for example, your device is having some Bluetooth and NFC capability. The developer has to, expose that API to the bridge. You have to implement a code that tells that this Bluetooth API can be accessed from the, from the web view. So what happens is like, along with that, the permission should be there. Bluetooth permission should be there. Okay, so now let's consider, we have an over permission, like an extra permission called NFC permission. And we are not using it, but the developer unknowingly give that extra permission. So this is an overprivileged application. And similarly, consider the same with Tizen web app. So Tizen web app, they have a Bluetooth permission and NFC privilege. So the NFC privilege is an over privilege. It's not needed, it's nowhere used. And the developer is actually making use of the Bluetooth API provided by the Tizen web API and calling the Bluetooth. He's not making use of NFC API, but it's there. It's already implemented and provided by Tizen. It's there. So what happens if an access occurs? So in the first case for Android, some access occurs. What happens is that this access can interact with the Art JavaScript interface. Whatever label you give, you can call that. And basically, as Bluetooth permission is there, it can directly access that exposed API provided by the developer and access your Bluetooth. But even though that's an over permission, NFC is an over permission, thing is that API is not exposed. It has to be exposed by the developer. He has to write it. So its impact is less, right? That API is not exposed, so the impact is less. But the same thing you go with Tizen, what happens is that all the API, the web API is already implemented there. So if you have an access there, and you have that permission, permission is a must. So if you have that NFC permission and Bluetooth permission, you can basically write your JavaScript that will access the NFC API, and even you can access NFC as well as Bluetooth. So that is an issue that Tizen can come up. So in order to mitigate that, they have something called the CSP. So basically that CSP is mandatory. But I mean, it's a new standard basically. I mean, if you see about a lot of the website or web application in the internet, I'm pretty sure like very few use CSP. Also, it's very difficult to use CSP for a very complex application. So CSP is still there, but if CSP is gone, I mean, this opens up a very huge attack surface. Whatever the permission is there, and if an accessor can access almost anything, if provided the permission is there. So that is one scenario. Okay, Shellshock, I got nothing to talk about it, no comments. It should be there because it's based on a Linux thing, so this is a legacy bug, it's already there. I'm not talking about the exploitation or whatsoever. So Shellshock was there, is there. And yeah, now let's talk about DEP, that is a data execution prevention. So basically, if DEP is there, what happens is that whatever data you have in the you have in the stack, it will be only having the read and write permission. It cannot execute. So if DEP is there, that means that the stack is non-executable, right? And it prevents your shellcode from executing. But DEP was actually not seen in action, so I have a demo for it. So this is a Tizen IDE where I used to develop a sample Tizen application. This is a native CPP application. And here you can see there is a character code array which is having my shellcode. This is nothing but an exit shellcode. Move12AL, EB, SOAR EBX, and then call the interrupt, and basically your exit shellcode. So if DEP was there, if I try to put this in stack and put it in stack and try to execute it, what happens is that it should not allow the code to execute. That is the exit shellcode to work. So what I'm going to do is I'm running a Tizen emulator. This is a Tizen emulator, just like your Android emulator. And I'm just running that code. And you can see a thing like buffer has closed unexpectedly. It is nothing but your exit function got executed. So buffer is the name of the application. So that is the issue. DEP was not even there. Even though they bossed a lot on the security, DEP was not even there. So that is one thing. And moving on to the presentation. ASLR. So as per the documentation of Tizen, ASLR is fully implemented in Tizen 2.1 itself. My research is actually focusing on Tizen 2.2. So already it was found, it was broken by another researcher called, I know how to spell this, some S. Suzuki. So this guy actually broke it. So what he found out was that if you see the /proc/sys/kernel/random_v_space, it's set to 2. So that basically means that ASLR is enabled. But what they did is like, there is something called the personality value. So if you see the /proc/self/personality value, it was set to 0040000. If you check the personality.h file over the internet, this value actually corresponds to address no randomized. So that basically tells that enable ASLR by calling the other thing and disable this. So they're actually by default they're disabling it. But it was actually patched in Tizen 2.2, which is my focus, which is on my focus. So what they did is they set this value to something like full of zeros, and it was not documented there. I was not able to find what it corresponds to. And also I found that every Tizen application by default, by default it's compiled with the PIE flag. So PIE is nothing but position independent executable. That means your executable will be ASLR enabled. That's it. So it was still enabled with that, but still there is some issue with the implementation, and even now the ASLR is broken. So I will show you a demo of what is happening there. So this is another native application written in Tizen. Basically does nothing. If you click on the app, it will open up, and there is a button, OK button. And if you press on OK, it will basically exit the app. That's it. So there is an OK button. If you click on OK, it will exit the app. Okay. So you can actually interact with the shell. The emulator actually allows you to do that. So if I just, I'm going to the project properties, C++ build and settings. You can see the flags they are using for compiling it. And you can see that there is FPI, that is position independent executable. That means it should be ASLR enabled. And okay, so I'm just going to the shell, and I'll show you those values which I talked before. That is cat/proc/sys/kernel. So basically, if you check that value, we can see that that's set to 2. So that means ASLR is enabled. And now if you check that personality value, you can see that it's set to 000. Okay, whatever. Now let's run the application and see whether ASLR is working or not. So I'm just taking another shell so that I can actually show you that memory map and all those things. And I'm running the app ASLR. So just give a PS AUX. So that will list out all those things. I actually want a PID from there. So here we have something called, in the last but one line, if you see there is /op/ something is there. So we actually want a package ID. So that we will get from the ID. So this is the package ID, APSCI, something like that. So that's the last but one thing. opt/app/APSIC. So that is the ID. I mean, that's a package ID. So you can see that it's running under app, and the PID is 4305. So what I do is I'll just print out that map. So /proc/ the PID, that is 4305/maps. Okay, so now you can see that the addresses there, the base addresses and all those things of all the libraries or modules that are loaded, and as well as the binary. So you can see that there is ASLR.exe. It's not your Windows exe, but they are actually keeping their binary format to be .exe. I don't know for whatever reason. I'm just taking another shell, and meanwhile I think I quit that application. Just a sec. Yeah, here I'm pressing OK, and I'm quitting that previous instance, and I'm starting another instance, just to be clear. And I'm again trying to figure out the same thing. So now I'll again issue the ps aux command and find out the PID. So that will give me the PID. Again, now the PID is 4315. So I'll again print the map of that PID. So if you see if you compare both of them, they're actually loaded at the same instance, even if you run the app for multiple times. So that's not a supposed behavior. If ASLR is enabled, their base address should be rebased. So that is not happening here. I'll just show you that. So check the addresses on the left side. Compare both of the addresses. They are exactly the same. Is it visible? Yeah, I can zoom it. So see, compare the address. It's exactly the same. And that is not the supposed behavior if you have ASLR enabled. So ASLR is broken anyway. I mean, these are some of the core things that an OS should have in terms of security. But let's see. Okay, so those were the two things which I did on the OS level things, like ASLR, on the memory protection basically. And now let's talk about the URL address spoofing or content injection. So this was I actually first around the WebKit browser they were using. So the default Tizen browser was WebKit based. So I was able to find out that it opens up a new way of phishing, I would say. Whatever, I don't know like what is the exact term to tell. But it's like URL spoofing or content injection, whatever. I'll explain what is it. So what happens is that your JavaScript can open a new window, say facebook.com, and you can actually write arbitrary code into it. So the new tab will be facebook.com, and the content will be whatever the attacker is controlling. So this was actually a previous WebKit bug which went unfixed in the Tizen WebKit actually. So I also have a demo for that. So I have a POC page which is loaded in my blog opensecurity.in. So when you click on that, when you execute that page, what happens is a new tab open, and it will be having a content you have been hacked. If you see the URL, it's like about : blank, and just check the source code actually. So the source code it's having nothing but we create a variable which is on which we assign window.open https facebook.com, and on the same variable we actually try to write w.document.write our arbitrary content and then focusing that window. So in Chrome you can have different tabs, but in mobile operating system, whatever you focus that will come in the first. You are not tracking. I'll explain that later. So that's it. So the supposed behavior is that whatever you open in a new tab, it should show something like about.blank or new page or something like that. So here I have the Tizen browser running. I'm just giving the same URL over there. And I click on enter, and you can see that at the bottom there is facebook.com, and at the top the content is you have been hacked. So basically it's like you can actually control the new tab, even the URL that is getting appeared over there. So if you see that there's a two tabs open, but in mobile it's like the one you are focusing will come in the top. So you have that top tab, and it's having the content you have been hacked, and the URL is https:// So basically, how will you distinguish a phishing attack? You look at the URL, right? So now what you can do? So that is one thing I was able to find in the Tizen browser. And then moving on. So I was also able to find out a CSP bypass actually. So this was something depending on a JavaScript null byte trick which was previously documented and was found in some older versions of WebKit. So this was still working perfectly in Tizen related that Tizen's browser. So what happens here is that I actually try to create a new script tag with the source pointing to a JavaScript file. Sorry, before that I'll define a content security policy which tells that load everything from the same domain, load the script from the same, whatever script JavaScript you have, load only from the same domain. So that means you have google.com, load every JavaScript that gets loaded should be only from google.com. It cannot be from microsoft.com or whatever. So I have a content security policy defined over there. So I was able to bypass this. What I did is like I prepended a JavaScript null byte to a URL, so which basically tricked the browser, and it was able to bypass that CSP. I'll show you a demo of that also, and I'll explain more once I come to the demo. So here I have a page, again a POC page in my blog. So the domain is opensecurity.in, and if you check the source code, there's a button, and when you click on the button, a bypass function is called. Inside that bypass function, I'm actually dynamically creating a script tag, nothing else. It's just script src is equal to a URL. I'm just dynamically creating it. So it's like document.create script, put some ID to it, and if you check that a.src, you can see /u000. So that's a JavaScript null byte. And then a URL which points to rowgit.com. So that's a JavaScript file that is actually hosted in GitHub. And I'm actually appending that script to the body. So that's what I'm going to do. So the typical behavior is like, before that I'll show you what is the content of that script file. So if you load that script file, you can see something like alert, hey, I am from GitHub. That's it. So if you just go back and I'll just go to inspect element. I want to show you the header actually, CSP header. So I'll refresh the page, and Yeah, so if you look here, the response header is having a content security policy, default-src self and script-src self. So all the scripts should be loaded from the same domain, that is opensecurity.in. You cannot load it from somewhere else. Yeah, so I was running this on a latest Chrome actually, so you'll see what is the expected behavior. So if I go to the console tab, there is already an exception, and if I press on that button, you can see that an exception is happening. It's telling that it's a violation to CSP. So this was actually fixed in the WebKit version for the Chrome. So it's telling that it's a violation, it's a CSP bypass that is, sorry, not bypass, it's a violation to CSP, and it is detecting it. Let's see what happens if we do the same thing on a Tizen browser. So I'll give the same URL on Tizen browser. So if I click on that CSP bypass button, the expected behavior is that nothing should happen. But it basically bypasses the CSP and execute the script from JavaScript, from GitHub domain. So that's about the CSP. I think I have only 5 more minutes, so let's quickly move on to the presentation. Okay, so that's all about the thing which I found in the Tizen operating system. Now, anyway, I'm sure that this is going to be shipped soon. So Tizen phones are already available in India. You can buy it from Flipkart, Amazon. It's very cheap. Tizen TVs are already available, but it's very expensive, like 3 lakhs, 4 lakhs, 5 lakhs, something like that. It's high-end TVs actually. But whatever you get, just buy it and give it a try. I'm just saying. So anyway, some of the people here will be pen testers, so you will be able to, in future you will be needing to, do the pen testing on Tizen related OS. So I'll just give a pen testing methodology on that. So basically you can have white box or black box. Like in white box you have access to the source code, you know what is the logic of the application, and you are doing the testing. And black box is just the opposite, you don't know anything about it, you are just blindly testing it. And the approach can be categorized as static analysis, dynamic analysis, or network analysis. And it's basically similar to the way you do with, say, for example, I'm actually concentrating on that Tizen 2.2 mobile version. So it's similar to what you do with Android only. So you can do that certificate signature analysis. Like you can make sure that it's distributed and developer sign. Who is actually signing it? Is it the right developer and the right distributor? And then you can do the same thing. That's a manifest analysis. Like for TP case, you can have manifest.xml. For WGT, you can have config.xml. And you can look for unwanted privileges or over privileges. How the CSP is implemented. Then the SMAC labels and rules. What are the permissions given to the directories, files, DBs, etc. And obviously the code review part, like all those weak encryption, crypto, plain text. It's using C++, so there is high chance for a buffer overflow. So you have to do all the code review things properly. And then the dynamic analysis. So as of now, there is no any other tools available, but I'm actually working on something automated static and dynamic analysis framework on Tizen, which probably I'll be presenting on HITB Amsterdam. And right now, what you have is a thing that is shipped with Tizen. That's you can actually run the app in the VM or the web simulator, and then you can look for all the sensitive data that is being shared, all the IPC, the sensitive files that are being created, etc. And the tools which you can use is the dynamic analyzer, which is much similar to your Android DDMS or Android device monitor. And they have something called SDB, which is just the exact copy of ADB. The only difference is instead of A, they have an S. So the other one is Android device bridge. This is smart device bridge. And I'm thinking it's pretty the same. All you have to do is just replace all the S with A. So even every option is same for this one. And you have this by default dynamic instrumentation framework provided by the Tizen. You can actually analyze and do all those dynamic analysis thing. And obviously the next important thing will be network analysis. So how you will decrypt and analyze the SSL traffic. So again, the OS top 10 for web will apply there, because if you have a server-side logic and all, if you have, then moving on, this is how you have to install the CS certificate. So for every trusted CS certificates are actually installed under /etc/SSL certs. So what you have to do is like, the naming convention is like, it's a string of 10-digit length. The 8 characters are some hex and followed by a dot and then a 0. So what you have to do is create a file, export your burp certificate, convert it to PEM format, then push it to this particular directory, /etc/SSL/cert. So there you go. You can actually intercept the traffic from now on. So with that, I'm talking about some security concerns which I feel. Basically, the web application is using WebKit. So there is one famous saying by the Greg actually. So WebKit is nothing but it's a collection of use after free, which somehow managed to execute HTML by buffer overflow in OpenGL and in WebGL. So that is a famous quote on WebKit. And if you see the news or whatever that is released, there's been a lot of issues or exploits or vulnerabilities based on WebKit. So I don't know whether it will be a good thing to go on. But I would say like a lot of people are investing on WebKit. So there's a high chance that they will actually, they'll take it in a serious manner. And we can see that in future, because of all these people, it will become secure. Who knows? Let's see. I mean, the developers are actually just pushing to the market. And one more thing I would say is like the HTML application is very powerful. The JavaScript is very powerful. You can actually access every device functionality provided the permissions are there. But the thing is like if an access is there and the permissions are improperly given or overprivileged, basically it can access anything on your device and accesses. So think about the power of accesses there. And about the SMAC rules, it's something like it's very complex, 41,000 lines or 41,000 rules. So when you have a lot of things complex, it's high chance that people will mess up. That's also one thing I see there. Let's see how it goes on. And I'm concluding my talk. So the security model or architecture, I would say they have put a lot of effort compared to other operating systems. They have done a lot of work. But they made it so complex that sometimes people can mess up. That is one thing. But I think like it's a promising thing. It's still being developed. It's still being frequently updated. A lot of patch fixes are happening. So I think this will be a promising platform. So that's all from my talk. And I would like to thank my amazing manager, Sachin, for giving me all the support and encouragement to do this research. That's all. Thank you. If you have any questions, I think I can take one or two now.
Any questions?
What's the footprint of the operating system? What's the size it takes?
It's something like, I didn't actually check, something like the VM image is something like 1.5 GB or something. The thing is like, this OS is very lightweight, and the advantage is like, it provides every feature that your Android provides, plus those features your Android doesn't provide. And it's very lightweight. The native application can be written in C++, that is one advantage. And it's very lightweight. Even a 700 MB RAM-based device will run the device like flawlessly. If you want to check out, you can buy a phone that's actually available in the market. I ordered it, but I was not able to get it now. So it's a Samsung Z1. It's a $5,000 Tizen phone, which is running Tizen 2.3. And if you see the device functionality they are having, it's very less early. But it's working it's operating very flawlessly. That's what I was able to understand from the reviews and all. And that is what they are saying. I didn't test it personally. I made to get the device actually. Yeah.
Any more questions?
Okay. So I think that's it. Thank you.
Thank you.